Hi, hello, good morning all. Welcome to my channel, Vijay Physics Sprints. Today I am going to cover about projectile motion on inclined plane and two previous sessions based on oblique projectile and as well as horizontal projectile. So follow those two videos on projectile motion, and this is the third part, the projectile motion on inclined surface. Okay. So already we know about oblique projectile. So oblique projectile means, and this is an example of oblique projectile. The angle with the horizontal, it is alpha, theta, whatever it may be. So this is angle with horizontal, it is theta, is oblique projectile. The body is projected with velocity of u. Okay. Just simply imagine an inclined plane. Inclined plane. Now it is like a projectile motion on inclined surface. Is a projectile motion on inclined surface. Right? The angle of inclination is alpha, and the projectile motion with horizontal it is theta. So the resultant angle it is becomes theta minus alpha. The body is projected up with velocity u. Right? Just imagine a coordinate system. Is a coordinate system y dash x, and this is x dash. So the velocity u is resolved into two components such that horizontal component as well as vertical component uy, and this is ux. What is ux? Ux is equal to, that is u cos theta, but theta with respect to inclined surface is theta minus alpha, and uy is equals to u sin theta minus alpha. So this is the initial velocity resolved into two components, horizontal and this is a vertical velocities ux and as well as uy. Now the gravity g value, right? G, gravity always downward direction. Now resolving into two components, horizontal and vertical. This is alpha, so this is g cos alpha and this is g sin alpha. Horizontal component towards the negative x-axis, so horizontal velocity ax is equals to minus g sin alpha, and vertical acceleration ay equals to towards the negative axis, that is minus g cos alpha. So these are the velocity components and these are the acceleration components. Now I am calculating what is the time of flight and what is the range. So here the body is projected up on inclined surface. Later we will discuss about the body is projected down from this inclined surface. So when the body is projected up, what is the time of flight? How much of time required to reach the maximum height? So reach this point. The time of flight I am calculating. So applying the second equation of motion, y equal to uyt plus ay t square. Reaches to this point means on x-axis y component is 0. The coordinate of y is 0 is equals to uy. What is uy? That is u sin theta minus alpha, time period, time of flight, and of ay. Ay value is minus g cos alpha, so minus g cos alpha into t square. So this is the quadratic equation in terms of time. So 0 equal to u sin theta minus alpha into t of g cos alpha into t square. So bring this side, that is of g cos alpha t square equal to u sin theta minus alpha into t. T is cancelled out. So time period t equals to 2u sin theta minus alpha by g cos alpha. So this is the time of flight. For the projectile motion on inclined plane when the body is projected up. So the time required it is t is equals to 2u sine theta minus alpha by g cos alpha. Now I am calculating range, horizontal distance covered by this projectile motion. Range I am going to calculate it. Okay, already we derived the time period, that is t is equals to 2u sine theta minus alpha by g cos alpha. Now I am calculating range. So that is x is equals to uxt plus half axt square, the second equation of motion. X is nothing but range or ux. Ux is equals to u cos theta minus alpha. T, time already calculated, that is 2u sine theta minus alpha by g cos alpha 1 by 2 ax, that is minus g sin alpha into t square. T square is nothing but 2u sine theta minus alpha by g cos alpha whole square. So this is the expression for range. After simplification, we will get the range value r is equals to u square g cos square alpha sine 2 theta minus alpha by minus sin alpha. So this is the expression for range, u squared by g cos square alpha sine of 2 theta minus alpha minus sin alpha. If this 2 theta minus alpha value is pi by 2, 90 degrees, then the value of range, it becomes maximum. Maximum range, that is u square g cos square alpha sin pi by 2 1 minus sin alpha. So this is the expression for maximum range when the body is projected up on inclined surface. This is for time period, sorry, this is for time of flight, and this is for range, and this is for maximum range value. Okay, now the body is projected down from inclined surface. So the body or the projectile is projected down like this. So what is the time of flight and what is the range? It is very simple. Is comparing previous case is going to be very easy. So angle of inclination is alpha. The velocity of the body, it is u. Okay. So just imagine a coordinate system. Just imagine a coordinate system. Okay. X, y, y dash, and this is x. So u is the initial velocity of the projectile, and the horizontal angle of projection is theta, and the alpha, of course, it is also is equals to alpha. So total angle with inclined surface is theta plus alpha. Now u resolve into two components, such that horizontal component and as well as vertical component. So what is horizontal component? Ux. Ux is equals to u cos theta plus alpha, and uy equal to u sin theta plus alpha. Now acceleration, ax as well as ay. So gravity, g resolving into two components, same as the previous case, that is g cos alpha and this is g sin alpha. So ax is equals to g sin alpha, ay equal to minus g cos alpha toward the negative y-axis. So minus g cos alpha. So again calculating time period, time of flight and range. So time of flight, applying same equation, that is uyt plus of ayt square. When it reaches to on x-axis, the y value is going to be 0, y coordinate is 0, 0 equal to uy, that is u sin theta plus alpha into t of ay, that is minus g cos alpha into t square. So bring this side, of g cos alpha t square equal to u sin theta plus alpha into t. Of course, t is going to be cancelled out. Therefore, time period t becomes 2u sin theta plus alpha by g cos alpha. This is for time of flight. Now calculating range. Same previous derivation only, similar to previous derivation, right? Range, I am calculating range. For range, that is x is equals to or r is equals to, so x is equals to uxt plus of ax t square. X nothing but range, ux is nothing but u cos theta plus alpha, time of flight just now I derived 2u sin theta plus alpha by g cos alpha 1 by 2 ax. Ax is nothing but plus g sin alpha into t square, that is 2u sin theta plus alpha by g cos alpha whole square. After deriving, we will get the final equation, that is r is equals to u square by g cos square alpha sin 2 theta plus alpha plus sin alpha. So this is for range expression when the body is projected down from inclined surface. If theta 2 theta plus pi alpha value is pi by 2, then the maximum range will get R max is equals to u square by g cos square alpha 1 plus sin alpha. This is for maximum. About these two concepts, when the body of projectile is moving up on inclined surface, time of flight, that is 2u sin theta minus alpha by g cos alpha. When it is moving down, time of flight 2u sin theta plus alpha by g cos alpha. Now range, that is r is equals to, when the body is projected up, range, that is u square by g cos square alpha sin 2 theta minus alpha minus sin alpha. And in this case, when the body is projected down, then range r is equals to u square g cos square alpha sin 2 theta plus alpha plus sin alpha. Okay, and of course maximum range, then you can take 2 theta minus alpha is pi by 2, they will get one more equation. Here also for maximum range 2 theta plus alpha is pi by 2, you will get the maximum range equations. Okay, so these two concepts I explained in this video, and the previous two videos is based on oblique projectile and horizontal projectile. Please follow those videos also, and if you have any doubts, you can make the questions in comment box. Thank you. Like and share, subscribe my channel. Thank you all.